This conference will now be recorded.
Welcome everybody to the Satellite Book Club. My name is Matt Siebold. I'm the Gozar Data Operations Manager. This is Satellite Book Club session number 114. Today's talk is entitled Use of the MOSHE Parameter to Identify Tornadic High Shear Low Cape Environments, an examination of October 21st, 2021. Our presenter today is Doug Kahn, who's a meteorologist from the National Weather Service's Forecast Office in Cleveland, Ohio, CLE. And today's facilitator is Linda Gilbert, the lead meteorologist from the Weather Service Forecast Office in Marquette, MQT. I'd like to remind everybody that today's session is being recorded. A question and answer session will occur after the presentation. I highly encourage attendees, especially those from the forecast offices and the regional headquarters, to please post their questions in the chat room, and we will field your questions from there through the chat. I'd also like to encourage attendees to please sign in with their full names or to specify their names when asking a question in the chat. We're looking for future presenters, and if you're interested, please reach out to the Tower S teams, Lee Byerly or Kashad Bauman. And if anyone is interested in training materials associated with today's presentation, please reach out to the training POC, Brian Mata. And Kashad has posted the relevant emails in the chat. Thank you again to the Tower S teams, Kashad Bauman, OCLO, Gozar, and JPSS, and to Linda facilitating here today. I'm delighted to introduce Doug Kahn. He's been a meteorologist with the National Weather Service at the Weather Forecast Office in Cleveland, Ohio for just over 3.5 years. He's originally from the Baltimore, Washington, D.C., Virginia area, which is where he spent the first 21 years of his life and received a bachelor's degree from the University of Maryland in College Park. Doug then moved to Alabama for 1.5 years to begin work on his master's degree, utilizing data from the geostationary lightning mapper at the University of Alabama in Huntsville. He then completed his master thesis shortly after accepting the position with the Cleveland office, where he serves as the satellite and fire weather focal point of contact. Doug, welcome to the Satellite Book Club. Please begin when you're ready.
All right, thanks, Matt. Thanks, Linda, for facilitating this session. So today we're going to be sort of going over a sneaky event in one of our shoulder seasons of late fall of 2021. So a general outline for the event is I'll give an overview of all the different tornadoes LSR reports that we received from the day, sort of go over a forecast progression from days 1 to 3, show some satellite and radar imagery from the event, go over the mesoscale environment, introduce everybody to the MOSHE and SHERBE parameters. And then something new that I added for this presentation in the last couple of weeks is utilizing the MOSHE actually in AWIFs for potential future high shear low cape events. So some quick facts from the event. The loop on the right shows the LSR reports with the associated radar from the day from 3 p.m. to 8 p.m. So the environment was favorable for embedded low-top supercells, generally along a broken line of thunderstorms. In our area, the CWA, there were 8 weak tornadoes, 4 of which were EF1, 4 of which were EF0. There were an additional several tornadoes in the Pittsburgh area, but this presentation will solely focus on the tornadoes that occurred in our area. The longest path length was around 3 miles, where the largest width was only about 50 yards. All the tornadoes generally occurred in our area between 4:30 and 6:30 in the afternoon and early evening, and there were 0 injuries during the course of the event. So here's MRMS rotational tracks. This is the low-level rotational tracks from October 21st, noting several different areas of moderate rotation across our area, and then also continuing into the Pittsburgh area. Here's the LSR map of the event, showing the different wind and tornado LSRs that we compiled from the event, once again extending into the Pittsburgh area. Here are those 3 areas that we'll be honing in on through the course of the presentation, at least in our area. kind of lining up right along that broken line of thunderstorms that we saw in the previous loop in the beginning of the presentation. So what about the forecast? So even though the potential for severe weather was apparent with the SBC outlining the area and a day 3 marginal risk, they did maintain the marginal risk up to and even through the event. The main risk, even up to day 1, the morning update in day 1 was generally the possibility of damaging wind gusts. There was never any possibility of greater than 2% tornado risk for the day. So here's the day 3 outline showing our area and Pittsburgh's area and a marginal risk. And the discussion remained fairly consistent throughout the event, with dew points in the mid to upper 50s, noting low top convection, unidirectional southwesterly winds, and the overall threat should remain limited due to the marginal thermodynamic environment. Day 2, nothing really has changed, with that center image showing the 5% risk of damaging wind gusts, and the right image is the tornado image showing less than 2% in all areas. Similar discussion in day 2, weak instability, less than 400 joules per kilogram MU cape, and that's actually about what we saw, around 250 to 500 joules per kilogram of cape for the event. Day 1, the marginal risk was extended down towards the southeast, as was the damaging wind gust threat. Tornado threat still remained less than 2% in all areas, and that was the early morning update, day 1. Similar discussion. Now we have our bulk shear values in the 40 to 50 knot range, steep low-level lapse rates, but once again, the weak instability. Although in the last sentence, they did mention that an isolated supercell cannot be ruled out. Now, this was during the event 20Z update, as the storms were sort of getting going in our area. SBC did introduce a 2% tornado risk for our extreme eastern half of the area and the Pittsburgh area. So this is the SBC discussion on the 20Z update, noting that they did introduce a small 2% tornado probability over the upper Ohio Valley region, also utilizing some of the satellite imagery at the 20Z update. So now we'll go over some satellite imagery from the event. I actually just got this made a few days ago. So this is an air mass RGB coupled with all of the different water vapor bands from the GOES satellite. So the top left is the air mass RGB, top right is the low level water vapor, bottom left is the mid-level water vapor, and bottom right is the upper level water vapor. One thing I like about the air mass RGB, it's one of the satellite products that I have in my suite of procedures when I load up AWIPs on a day-to-day basis. I like it because it can sort of show all of the different synoptic features in one product. Now, for example, I'm showing in the top left in the air mass RGB product, I'm showing the that white circled area, that outline region, and that's where the bulk of the event occurred. Something that you can see or note with the air mass RGB product is when you have those blue colors, especially within the convection, you have a more continuity of moisture depth, and that can note that there was modest moisture, potentially more than some of the models were suggesting for the day. Another thing you can also see in the air mass RGB product is the upper low spinning across Michigan, which climatologically is favorable for our high shear low cape environments in the Great Lakes region. There were some reddish colors within that upper low, noting potentially higher potential vorticity air. Next, we'll move into one of my favorite daytime satellite products, the Day Cloud Phase Distinction product. So this is also an RGB satellite product, which has contributions from 3 different GOES bands: the clean IR, the red visible, and the snow ice band. So the next few slides will sort of show this RGB product along with its individual contributions products. So here's a static satellite imagery at 2:30 p.m. Just a couple hours before the first tornado report. So a few things to note here. First, we'll look at the white outline area, sort of showing if you look off to the east, there was some morning convection noted by some of the convective clouds and even lingering cloud cover across northeast Ohio. But there was a small region of clearing behind the morning convection, noted by some of these agitated Q developing right ahead of the cold front. And this is readily seen in the day cloud phase distinction product, which is in the top left, as well as the red visible band in the bottom left. The other two bands in the top right are the clean IR and the snow ice band in the bottom right. Another thing to mention is the cloud glaciation, which you can see in the day cloud phase distinction product. So potentially, the instability was a little higher than some of the models were anticipating. So here's again the satellite imagery at the 3:30 update. Another thing I like to do in conjunction with the day cloud phase distinction product is have the clean IR actually overlaid on the day cloud phase distinction product. I like the day cloud phase distinction product for convective initiation, and then I like to overlay the clean IR on top of the RGB once the storms are more in their mature phase, because then I can sort of see how the cloud top temperatures are cooling, as well as get that readout of how cold the cloud tops are. As you'll see in this next image at the 4:30 update, or the 4:30 timestamp. This is around the time when we reported our first tornado, which was an EF1 in Medina County, which is one county south of the Cleveland area. And then shortly thereafter, 8 minutes later, a second tornado, weak EF1, was reported in the same county. Now note that at this time, the cloud tops are fully glaciated, noted by the day cloud phase distinction product in the top left, as well as you're starting to get colder cloud tops in excess of -40°C by the clean IR image in the top right. So here's some flash extent density information from the GLM from 3 p.m. to 6 p.m. Eastern Daylight Time on October 21st. That red T indicates that location of the first tornado around 4:36 p.m. So you're just looking at the GLM static color bar here. There really isn't too much signal in the flash extent density. You do actually see some higher flash extent density in the southern cell, which did not produce a tornado. But this is sort of what one would expect, given the very low instability environment. Especially this is probably the early stages of the line developing. The flash extent density did increase as the line moved into the Pittsburgh area. Now, one thing that would be interesting to see would be the minimum flash area, to see if it would have been more useful in potentially detecting those smaller, more localized updraft regions versus the flash extent density. Here's some radar imagery loop from that first tornado in Medina County. So again, there was a weak signal in the velocity. It did not last very long. It was very brief, but it did. This was the fall, so there potentially were more leaves on the ground, which may have resulted in the TDS becoming more apparent, which is in the bottom left, which is the correlation coefficient product. And then the bottom right is the MRMS low-level rotation track. So next we'll go into the mesoscale environment. So initially, a few things stood out during the event which differed from what we expected. One was that the instability was slightly higher than forecast, which is typical for all of these high shear low cape events. Another thing were that the low-level shear profiles were not entirely unidirectional from south to southwest winds ahead of the line. So I'll sort of go into this reconstructed photograph the next slide here. So I took some level 3 data from the Cleveland radar, put in a south wind at 10 knots at Cleveland, and from the 0 to 500 layer, I got around 85 to 100 SRH, with slightly higher 100 to 125 at the 0 to 1 level. Not necessarily too strong, but enough to elicit some concern about some weak, potentially spinning, weak tornado potential for the day. Now, note above the 3 kilometer, the photograph gets fairly messy, which owes to this low-topped environment. Now, in the post-event review process, something we've done here in the last few years for any of our major events, we looked at various parameters from the SBC meso-analysis page, but one composite parameter stood out among the rest, which was the modified SHERBE. This is what the modified SHERBE, the MOSHE, was showing at the bottom, which is the image in the right hand corner at 4 p.m. on October 21st. I'll go into a little bit of what these values mean, but generally anything more than 3, once you're starting to get into that pink-purple color, that means that the environment is extremely favorable for at least one severe weather report. Here's a loop of the MOSHE from 3 to 7 p.m. on October 21st, showing that sort of progression of the higher MOSHE values from starting in our area and being extrapolated, extending east into western Pennsylvania through the afternoon and evening. So some origins of the modified SHERBE. So it originates from the SHERBE S3. Main difference between these two products is the SHERBE S3 is just the bulk shear, and the SHERBE E is the effective shear. Now, effective shear is something that we don't, I'm not certain that we get in AWIPS, and that's something that I'll go in further when talking about the MOSHE and AWIPS near the end of the presentation. One of the main differences between the SHERBE and the MOSHE is that they took away the static mid-level lapse rates, 700 to 500 millibars, as well as sort of decreased the bulk shear, that low-level shear from 0 to 3 to 0 to 1.5. One of the main differences that I mentioned is this elimination of a mid-level lapse rate term, and then including this max TEVV, which is sort of like a change in the or a composite max theta E difference in the low to mid levels. So any value that's greater than 1 for the MOSHE is favorable for any severe weather potential not exclusive to tornado genesis. But in this case, we did have the turning of the winds in the low level. So it became quickly apparent that this was what we were sort of dealing with for the day. And then here's an image from the Sherburn paper from 2016, sort of just showing that anything that's greater than 3.5 for the MOSHE parameter is very favorable for any severe weather reports, and anything that's less than 1, you're probably going to have more null events than anything. Now, as of early March 2022, you can actually extrapolate the MOSHE out on the SBC meso-analysis webpage out to 6 hours using the RAP. But I'll also go into detail on how to get this in AWIPS. So here's a recent development in the last few weeks. We were actually able to get the MOSHE, not the MOSHE-E. Remember, the MOSHE-E incorporates the effective shear, which I don't believe we can get in AWIPS. But nonetheless, we can now load the MOSHE using the volume browser in via the RAP, NAM, any of the FV3 cores, and then the GFS. Now you can load as an image or a contour. I actually like overlaying this as a contour, sort of following a similar technique to what's being utilized for lightning caps. Sort of utilizing that new AWIPS build, and then overlaying it on something like satellite. So in this case, I took a image from this is in Canada a couple weeks ago. So overlaying the MOSHE parameter on the day cloud phase distinction product. So I think this can be useful not just in a forecast sense, this parameter, but also a nowcast mesoanalysis standpoint. Another thing to mention on the MOSHE parameters that will be zeroed out when the MU cape is less than 10 or higher than 2000, just to sort of hone in on those lower instability scenarios, because some of the models, especially in the most unstable cape, can be biased too high in some of these situations. So with that, I'll give everybody a link to our local event summary page, as well as this specific event. And with that, I'll take any questions and I'll end here. Thank you.
Thank you so much, Doug. This was a really fascinating presentation. It was really interesting to see you go through this. So thank you so much here. Just want to encourage everybody to please stay on for some discussion here. Definitely get your questions going in the chat, and we will go through those. But before we move on here, I did want to go ahead and plug here for next week, Thursday, September 22nd. Kevin Thiel from the Storm Prediction Center will be discussing the GOES/JPSS hazardous weather testbed results. And I have seen a presentation from him recently similar to this, and I must say that it's very exciting for sure. So I highly encourage those of you who can attend to please tune in next week, or definitely catch it once it's been recorded and uploaded later. And I also want to make sure that I encourage everybody here, if you do have any questions or need any sort of configuration of satellite products, to please contact the TowerS team. Lee Byerly and Kashad Bowman are the ones that you'll probably want to reach out to for any questions related to the Satellite Book Club, or like I said, for any of the configuration of those satellite products. And then you can also go ahead and find them in the NWS chat room, Tower-S. Okay, so yeah, like I said, please definitely stay on. Looks like we're already getting a question here in the chat room. Please make sure that you include your full name when you are asking a question, just so that if there is anything that the presenter or anyone that needs to get back to you on, that they know how to reach you. So let's just go ahead and jump right into it here. We've got the first question here from Frank Alsheimer. Have you thought about loading in both the image and the contours for MOSHE on top of satellite, then hide the MOSHE image? It would allow you to use the sample feature in AWIPS.
Yeah, I can definitely see that. I think I toyed with that a little when I was trying to use the image and make that sort of into a contour. Before the recent AWIPS build, that's kind of what you had to do to kind of a poor man's way of creating a contour. But I think that would be a good idea. That's what I do with the clean IR, for example. You know, if I'm trying to load the RGB sandwich product, for example, that's what I used to have to do to try to get the readout of the clean IR. So I think that is a good suggestion.
All right, great, thanks. And let's see, we've got another one that just came in from Stephen. Could you please go back a couple of slides so that I could capture the 2 links to this event? Thanks.
Yeah, sure. Can you see it? See my slide?
I know I can see it here. If anybody else is having any issues, definitely chime in and let us know. All right, and got a thanks from Stephen. I actually had a question here myself as I was, watching this presentation here. So you had mentioned about using some GLM products. You specifically mentioned the FED, and you had talked about how the MFA could be interesting. I agree. I think that would be really interesting to go back and look at. Did you happen to look at the TOW product at all? And if so, did you notice any signal there, or was that a product that you hadn't looked at either?
So I haven't looked at the TOA products yet. I know we can get that information. I actually just got the GLM FED images from Dan Bykos a few days ago. So I just started combing through that information. I haven't gotten the MFA information, but I think he did say all of the different parameters were possible to obtain.
Okay, yeah, that would be definitely very fascinating to hear about for sure. So, all right, thank you. So definitely keep your questions coming in. You should also be able to raise your hand and unmute yourself, or we can unmute you. So yeah, if you have any verbal questions, for those of you in the audience, definitely let us know. And I am seeing that Kashad is putting in those links into the chat box there for the local event archive as well as the specific event. So thank you so much for that. And there was another question that had come in. So the question here is, do you think that 1 minute satellite data would have aided in planning for staffing and/or warning/decision making?
Yeah, I think the 1 minute data is always helpful. I'm not actually sure if we had access to it during this event. I know the mesoscale 1 sector is usually defaulted over at least half of our area. I'm not sure if it would be the west or the eastern half of the area, but I do think, especially with the rapid initiation using the day cloud phase distinction product, just sort of looking at that glaciation rate of the clouds, it would have possibly been a warning sign to some of the forecasters on shift that, hey, we may need to staff up for this afternoon, later this afternoon and evening. Luckily, there were signs of rotation in that first cell that produced a tornado in Medina right at shift change around 4 p.m. So, I feel like this event could have gone a lot potentially worse if that rotation hadn't occurred as early as it did. If it happened 30 minutes later, we could have been talking about a completely different story with only maybe 2 people on shift and frantically trying to call everybody back in the office.
Sure. Okay. Yeah. Thanks for that that insight there. Appreciate that. Let's see if we have any other questions coming in. There is one other one here. Since this event, has your office utilized the MOSHE parameter in any other high shear, low cape situations?
So yeah, I mean, we started looking at it, especially after this event in the spring of earlier this year. Now we didn't really have too many additional high shear, low cape events in our area in the spring, but we did start to incorporate it into our meso analysis. At that point, you could really only use some of the ingredients to the equation, since you couldn't extrapolate it out 6 hours at that point on the SBC meso analysis page. I think going forward for this season, now that we can get it in AWIPS, we'll sort of test, evaluate how useful it'll be with the different models we can access the information via the RAP or the GFS or the ARW. The ARW models.
Okay, great. Thank you. Yeah.
Oh, sorry. I do have some additional slides if anybody was interested. Trying to apply to MOSHE for one of our more significant tornado outbreak events, 2017. Now this event had 14 tornadoes. It was more in the realm of modest instability, whereas our previous event was more on the realm of weak instability. So this event actually had a few EF2 tornadoes, but if you kind of notice here for the MOSHE parameter, the values were a little bit higher, more in the realm of 6 to 8, whereas our event peaked 3 to 4. So just another thing to consider when looking at the parameter. What we're going to have to evaluate how we want to do all the different color contours going forward, especially for our hair. But just another thing to consider.
Yeah, you bring up a good point there about going back and seeing if you can kind of look at past cases there. So yeah, definitely thanks for sharing that. That's great.
Sure, no problem.
All right. Well, we still have a few minutes here. Oh, we just got a comment here from Matthew. He says, "Great work, Doug. Thanks for sharing your experiences with this challenging event."
Yeah, it was definitely an interesting event. We've gone back at the post-event review process, and I think that's a really good thing that we've started to do here at the Cleveland office, is sort of do these post-mortems. And if we had never done that, we would never have found this parameter that proved useful in this event. So.
All right. We will give it just maybe another 30 seconds to a minute to see if anybody has any additional questions or comments. But I do encourage everybody here today to scroll back up in your chat window, and please make sure that you share any feedback that you have on this session or anything from or in regards to the Satellite Book Club in a short survey that they have linked there in the chat room. So like I said, you can go ahead and scroll back up in your chat box there. And that was posted by Tristan. You should be able to find that in there. And if you are having any problems, definitely reach out to the folks at the Tower S team and they can get you that link. But yeah, definitely share your feedback if you have any. I guess I'll give it just another 10 more seconds here for any other final comments, questions, anything like that before we go ahead and wrap things up. Got one from Joe. Great presentation. Thank you so much for that feedback there, Joe. All right, so at this point then, I will go ahead and turn it back over to Matt. Thank you so much again, Doug. This was great.
Yeah, thanks, Linda.
Yeah, thanks everyone for attending today. Special thanks to Doug for the presentation and to Linda for the facilitation. These meetings are, they're a fantastic opportunity for the Weather Service forecasters across the nation to engage in knowledge transfer. And we look forward to seeing you again at the next Satellite Book Club. Hope everybody has a great day. Thank you.
Thanks.